Hello dear students. Children, our next topic is reaction of metal with salt solution. Okay? In previous video, children, we have seen that how the highly reactive metals displaces less reactive metals. So children, the reaction of metal with salt solution is also depend on the reactivity of the metal. It means only highly reactive metals always displaces less reactive metals. Let us understand. Suppose children, this is metal A combines with salt solution. Suppose this is salt solution. Salt solution, and this is metal. Now what is the product form? So I've already told you children, you have to learn the reactivity of the metal. Which metal is more reactive than other. Clear? Now children, you all know it very well that the salt solution is the combination of positive and negative charge, and the metal which is positive charge. If metal A is highly reactive than metal B, then it displaces B and the product will be AC, B will separate. Concept clear children? The condition is that if metal A is highly reactive than metal B, then this possible can true. Clear? But children, if we reverse the position of metal, then what will be the product? See children, B is less reactive than A, so it cannot displace A. So the product will be, no product will be formed. So we can write no reaction take place. Concept clear children? Now look at this example children. Displacement reaction between iron and copper sulfate solution. Children, copper sulfate is a salt which is found in blue in color. Okay? Now the procedure is, you have to take one beaker and add 5 ml of copper sulfate solution which is blue in color. The whole solution will be in blue in color. Now put an iron nail in this. The color of iron nail is reddish brown. Okay. If we left this for a short while, we observe that the blue color of copper sulfate fades away. Okay. The conclusion is that the blue color of copper sulfate fades away and becomes green in color. See children how. CuSO4, iron and blue in color. Clear children? Now this is the reactivities of the metal. There is the iron and children, iron is more reactive than copper. Okay? So being more reactive, this iron displaces the position of copper and form FeSO4. Due to the formation of ferrous sulfate, the blue color fades away and finally becomes green in color. Okay. Now the copper will separate out. Easy children. This is the example between iron and copper sulfate solution. How the highly reactive metal of iron displaces the less reactive of copper from their salt solution. Clear? Now children, suppose if we reverse the position of metal, okay, for example, suppose this is ferrous sulfate solution FeSO4, which is green in color. If we dipped copper rod in that, will there any change? This is the question. What do you observe that when copper rod dipped in ferrous sulfate solution? So children, no change occurs in this reaction. No reaction takes place because copper is less reactive than iron. So it cannot displace iron. That is why no reaction takes place and no observation can be observed. Is it? Now let us solve the question, children. What will happen if copper rod, okay, is put in silver nitrate solution? Now, suppose this is silver nitrate solution which is colorless. Okay, is it always found in colorless, children? If we put copper rod, suppose this is copper rod is put in silver nitrate solution, what do you observe? What will happen? Clear, children? Before a reaction. Now children, you can see in the reactivity series, copper is above the silver. Okay, and keep in your mind that only above metal which are in the top of the reactivity series can displace the metal which are below in the reactivity series. Once again I repeat, the metal which are in the top of the reactivity series only can displace the metal which are in the below of the reactivity series. It means potassium can displace sodium from their salt solution, but sodium cannot displace potassium from their salt solution. Clear, children? Now, this is the position of copper and this is the position of silver. Now, copper is above the silver. So, children, copper can displace silver. Silver nitrate. So, it displaces the position of copper and form copper nitrate, and Ag will separate. This is colorless, children. When it displaces silver and form copper nitrate, the solution becomes blue in color. Clear? Now after reaction, it forms copper nitrate, and silver. The particles of silver can easily seen in the solution. Clear, children? And the whole solution becomes blue in color. Easy, children? Now see the next example, children. Will copper react with dilute HCl to evolve hydrogen gas? Sometimes, children, students got confused that sir has told me, sir has explained that when metal react with acid, it always liberates hydrogen gas. So will it be same in everywhere? No, children. The reaction of metal with also acid is depend on the reactivity of metal. Please note it down in the copy, children. Copper plus HCl. This hydrogen cannot be converted into a hydrogen gas until if copper displaces hydrogen. Okay, so children, if we see in the reactivity series, hydrogen is above the copper. It means hydrogen is more reactive than copper. So how can copper displace hydrogen? Now we can show, children, we all showed that no reaction takes place because copper is less reactive than hydrogen. Now children, the next topic is the chemical property of nonmetal. In previous we have study about, we have already completed the chemical property of metal with oxygen, with water, with acid, okay, with also their salts. Now children, the next topic which we are going to study, that the property of nonmetal. Okay, the first chemical property is electronegative character. See, the word electronegative, it means the element which have tendency to gain the electron and form negative charge, that is known as electronegative. Children, you all know it very well, and I have already explained that every atoms, they have only one aim. What? To become inert gas, to complete their stability. So every atom tries to complete their stability by losing electron and by gaining electrons. Okay, and those element which loses one electron to complete octet, they are called metals, and the element which gains electron to complete their inertness, that is known as nonmetals. Clear? Now all the nonmetals show electronegative character, means all nonmetals tries to gain electron and form negative charge. See children, how? Suppose this is oxygen, children. Okay, atomic number of oxygen is 8. If we write their electronic configuration, the K cell contains 2 electron and L cell contains electron. So if we see in the last valency cell, okay, it has only 6 electron, but to become stability, it needs to be 8 electron. Okay, so it needs to be 2 electron to complete their stability. So oxygen tries to gain 2 electron from other atom to become inert gas. So when oxygen gains 2 electron, it forms 2 minus. Now this is the electronegative character. Those atom which gains electron and form negative charge, they are called electronegative character. Another example you can see, children. Suppose this is chlorine. Atomic number of chlorine is 70. 287. It needs 1 electron to complete its stability. So when chlorine gains 1 electron, it forms chlorine minus. This is also electronegative. Understood, children? Very simple, that only you have to learn in your mind. You have to keep in your mind that non-metals always show electronegative character by gaining electrons from other atom and form negative charge. Now, the second chemical property of non-metal is reaction with water, oxygen, sorry. First you have to note in your copy, non-metals react with oxygen on non-metal oxide. Okay, and the nature of non-metal oxide is acidic. Now children, I know you are thinking that, sir, how the non-metal oxide is so acidic in nature. So I will explain, children. Let us take an example to understand this. Suppose I am taking one non-metal, carbon. Okay, when carbon combines with oxygen, it is very simple, children. It forms carbon dioxide. Okay, but children, how it shows this is a gas, children? How this gas show acidic behavior? This is the concept. If you want check the nature of this oxide, now react this gas with water. Okay, when it combines with water, it forms carbonic acid, and this compound contains carbon. Easy, children? In chapter 2, I have explained that those compounds which contain hydrogen ion will dissolve in water. So this compound contains hydrogen ion, that this is acid. This is carbonic acid. From second equation, we can say that carbon dioxide gas show acidic behavior. Clear, children? Now take second example. Sulfur. Sulfur is also non-metal, children. Sulfur is also non-metal. When sulfur combines with oxygen, it forms non-metal oxide, means SO2. Again, children, if you want to check this acidic, this gas react with water only. Okay, it forms sulfurous acid. Yes, it forms sulfurous acid. It means this non-metal oxide so acidic in nature. Clear, children? From both example. Children, non-metals do not react with acids, because suppose this is sulfur and this is Cl. No reaction. Children, you know why? Because sulfur cannot give electron to hydrogen to convert into the hydrogen gas. That is why all the non-metals do not react with acids. Fourth, oxidizing agent. Children, oxidizing agent, this topic has been explained in first chapter. The substance which gets reduced, that is known as oxidizing agent. So children, all the non-metals are very good oxidizing agent, because they all gains electron to other atom and get reduced. That is why all the non-metals act as a very good oxidizing agent. And fluorine is the most and good oxidizing agent in all. Fifth property is that formation of covalent bond, covalent molecule or bond, covalent compound. Children, covalent compound always found between two non-metal. Okay. So non-metal has property to form covalent compound because two metals shares their electron and form the compound. For example, H2, Cl2 children, methane gas. See children, hydrogen gas, one electron. By sharing, they can complete their octet. Chlorine children, atomic number 17, 287. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 6, 7. By sharing one electron, they can form covalent compound. Clear children? So, non-metal also have the property to form covalent compound. Okay children? Thank you.